Hi viewers, this is PHANI Kumar, Senior Lecturer in Chemistry. You are watching Crack Chemistry JEE NEET. Right, if you are watching for the first time, please like and subscribe. Please press the bell icon. On the request of few of the students, today I would like to discuss the concept of coordination chemistry. Right, without making any delay, let us come into our topic. If at all, if we observe the long form of the periodic table, we are having 118 elements. These elements are classified into three different types: metals, metalloids and non-metals. These elements react one with another and forms different kinds of the compounds. Broadly, we can classify those compounds into three different categories: acids, bases and salts. Today we are going to have a deep look into the one of the category of the salts. They are nothing but coordination compounds. Let us get into our topic. Right. So here let us take an acid, familiar acid, hydrochloric acid. If it reacts with sodium hydroxide, it will form salt and water, that is sodium chloride and water will be formed over there. Next, in the same way, if we take H2SO4 and if it reacts with KOH, then that will form K2SO4, a salt, and water will be formed over there. And let us take another weak acid, that is HCN. If hydrogen cyanide reacts with a weak base ammonium hydroxide, that forms a salt, ammonium cyanide, as well as water will be formed over here. Here, like this, whatever the salts that are formed by the reaction of an acid with base, if we mix either two or more than two salts one with another, and if they are dissolved in water and the solvent is evaporated, we will get some crystals. The so formed crystals are called as the addition compounds or molecular compounds. Let us take an example. Here salt 1 is taken and second salt is taken, and these two are dissolved in the water, and the so formed solution of two different salts, water is evaporated from this solution. Then we will get few of the crystals, and these crystals are called as the addition compounds or molecular compounds. Addition compounds or molecular compounds. Here these two salts are simply added in the stoichiometric proportions, or they are added in simple proportions. So like this formed addition compounds or molecular compounds are broadly classified into two different categories. They are called as double salts and coordination compounds. Okay, these molecular compounds or addition compounds are classified into how many types? They are classified into two different types. They are nothing but the first kind of the molecular or addition compounds are the double salts, and the second kind of the molecular or addition compounds are the coordination compounds. Let us have an example for the addition compounds and double salts and the coordination compounds, and then let us discuss about these two different kinds of the substances in detail. First example for the double salts, we can furnish Morse salt. A Morse salt is formed by mixing of ferrous sulfate and ammonium sulfate. Generally it is referred as ferrous ammonium sulfate. Its molecular formula will be FeSO4, NH4 twice SO4 and 6H2O. And the second kind of the example we can take cornellite. KCl, MgCl2, 6H2O. This is the second example we can quote for the what we can say double salt. And if you want, we can write one more simple example, that is nothing but potash alum. Its molecular formula will be K2SO4, Al2SO4 taken thrice, and 24H2O. Here, please students make a note of this. In few of the competitive examinations, they might ask you the number of water molecules which are associated with these double salts might be asked in one of the examination, one of the JEE examination. We got a question, how many water molecules are present along with the cornolite? Like these questions we can expect. Especially in the case of JEE, this year in JEE mains we are having numerical type of the questions. So in these numerical type of the questions, you can see here more salt is associated with the 6 water molecules. In the same way, cornolite is also associated with the 6 water molecules. So we can expect a question in JEE mains by giving either mole salt or cornolite and how many water molecules are associated with more salt or cornolite, like we can get the question. Now let us have a look on these double salts. What are double salts means? Simply if you add this double salt to the water, okay, add double salt to the water. When water is added to the double salt, simply that gets ionized completely. So double salts are the molecular or addition compounds which gets ionized completely in the aqueous solutions are called as simply double salts. Whereas if we came for the coordination compounds, the coordination compounds are the compounds which partially ionized in the aqueous solutions. The major difference between the double salts and coordination compounds is double salts are completely ionized in the aqueous solution, whereas coordination compounds are partially ionized in the aqueous solution. Here we can take an example, potassium ferrocyanide, K4FeCN taken 6 times. This is one of the example we can quote for the coordination compound, and a very familiar example. It is formed by mixing 2 different salts. It is formed by mixing of 4 moles of potassium cyanide and FeCN taken twice. By mixing the potassium cyanide and ferrocyanide, we will get potassium ferrocyanide. K4FeCN taken 6 times is obtained. So here if you dissolve, let us take one of the example here. Here let us take cornolite. If you take cornolite, when this cornolite is dissolved in water, KCl, MgCl2, 6H2O, when it is dissolved in water, then what happens, you can find the potassium ion in the aqueous solution, chloride ion in the aqueous solution. Totally you will get 3 moles of chloride ion here, as well as you will get magnesium ion in the aqueous solution. Whereas if you dissolve this potassium ferrocyanide in the water, simply you will get 4 moles of potassium ion and a complex ion will be formed, FeCN taken 6 times and -4 will be formed. Here we cannot find the presence of cyanide ion in the aqueous solutions of potassium ferrocyanide, which indicates these are a special category of the compounds which are partially ionized in the aqueous solution. So these compounds are called as the coordination compounds. How these coordination compounds are formed and which type of the elements will form the coordination compounds means these coordination compounds are formed mostly by means of the D block elements. Definitely the coordination compound should have D block elements. These D block elements, as they are having vacant d orbital in their valency shell, they receives electron pairs from the neutral molecules like water or ammonia, or they can get the electrons from the negatively charged species like chloride, bromide, sulfite and other species, and they will form a coordinate covalently bonded compounds which are referred as the coordination compounds. Which type of the questions we can expect from the double salts and coordination compounds means number 1, by giving few of the compounds they might ask you which of the following is a double salt and which of the following is a coordination compound. That is one category of the question we can get. And the second kind of the question, by giving the same type of the compounds, double salt and a few of the coordination compounds, he will ask you which of the following is having a highest electrical conductivity. If at all, if we observe the electrical conductivity of these compounds, double salts are having more electrical conductivity than that of the coordination compounds. If at all, if you are having all coordination compounds are quoted in the question, then the electrical conductivity of these coordination compounds, electrical conductivity of the coordination compounds is directly proportional to the number of ions that are produced by the compound in the aqueous solution. For example, if K4FeCN6 and K3FeCN taken 6 times, these two are given, and he might ask you which of the following is having a maximum electrical conductivity in the aqueous solution. Means when it is dissolved in the water, here you can see 4 potassium ions and 1 complex ion. That means total 5 ions are formed in the aqueous solution. Then if you take this complex, here this forms 3 potassium ions and 1 complex ion. So totally 4 ions will be formed. So the electrical conductivity of the potassium ferrocyanide is more than that of potassium ferricyanide, that is K3FeCN taken 6 times. Okay, these are the major differences between the double salts and coordination compounds. Now let's have a look on the classification of the complex compounds. How can we classify the complex compounds? Here the classification of the complex compounds is done based on the different parameters. The first parameter taken for the classification of the complex compounds is stability of the complex, which is unique, and you cannot find this kind of classification anywhere or in any other videos. Based on the stability, here we can classify the complex compounds into 2 different types. They are nothing but the first kind of the complex compounds are the perfect complex compounds, or here you can say penetrating complex compounds. Okay, perfect complex compounds or penetrating complex compounds. The perfect complex compounds or penetrating complex compounds are highly stable in the aqueous solutions. They does not get dissociated into the ions completely. They does not get dissociated into the ions completely. Here we can put the examples, 2 different examples, what we discussed already. Potassium ferrocyanide K4FeCN taken 6 times, and you can take K3FeCN taken 6 times. These 2 complexes you can take for the perfect or penetrating complexes. Second one is the imperfect complexes. Second category of the complexes is imperfect complexes or normal complexes. What are imperfect complexes or normal complexes? Means the complexes which are having greater extent of dissociation in the aqueous solutions. Whenever this is unusual activity of these complexes, here we are saying coordination compounds are stable in the aqueous solutions, but there is an example which forms a complex compound, that means a coordination compound, but when it is dissolved in water, that gets dissociated into ions in the aqueous solution. So such a kind of complexes which gets dissociated into ions in the aqueous solutions are called as the imperfect complexes or normal complexes. It is formed by mixing 2 different salts, that is potassium cyanide and cadmium cyanide. By mixing potassium cyanide and cadmium cyanide, we will get a complex with the molecular formula K2CdCN taken 4 times. This is having greater extent of dissociation in the aqueous solution, and when it is dissolved in water, that gets dissociated into the ions. Second kind of the complexes, and very familiar complexes, based on the charge. Based on the charge, we can classify the complexes. Here, based on the charge, we can classify the complexes into 2 different types. Based on the charge, how many types we can classify the complexes? The complexes can be classified into 2 different types. 3 different types. They are, the first kind of the complexes are the neutral complexes. That means here the complex does not carries any of the charge. If there is no charge on the complex, they are called as the neutral complexes. Here we are having two different kinds of the neutral complexes. They are nothing but simply let us take we are having PT NH3 taken 4 times and PTNH3 taken 4 times. This is one of the complex which carries a positive charge. And second example, PTCl4, it carries a negative charge. So altogether the total charge on the complex will become 0. And second kind of the example we can take tetracarbonyl nickel, NiCO taken 4 times. The net charge on the second kind of the complexes, here the net charge on the complex will be 0. And we can quote another example, that is CrCO taken 6 times. And we can take one more example, pentacarbonyl iron, FeCO taken 5 times. These are the 4 different examples we can quote for the neutral complexes. And the next kind of the complex we are having is the cationic complex. The next kind of the complex we are having is the cationic complex. That means when you dissolve this compound in aqueous solution, positive charge will be formed over the complex ion. If the complex ion carries a positive charge, they are called as the cationic complexes. Let us take an example. Here CuNH3 taken 4 times and SO4. If you dissolve this compound which is formed by the combination of copper sulfate and ammonium sulfate, copper and ammonium sulfates are mixed, you will get this kind of complex. The names of these complexes we will discuss in the next video. Here if you dissolve this complex in water, what you will get? You will get a CuNH3 taken 4 times and the complex ion carries a di-positive charge and sulfate ion is formed over here. So as this complex carries a positive charge, these are called as the cationic complexes. And the third kind of the complexes we are having are the anionic complexes. That means here the complex carries a negative charge. The best example from the beginning we are discussing, K4FeCN taken 6 times. When it is dissolved in water, what happens? You will get 4 potassium ions and FeCN taken 6 times carries a 4 units negative charge. So this is called as an anionic complex. So this is the second kind of the classification based on the charges. And the third kind of the complexes, the third parameter taken for the classification of the complexes is based on the number of kinds of ligands present in the complexes. Based on the third category taken for the classification of the compounds is number of kinds of ligands present in the complex. There are 2 different types we are having. The first kind of the complexes are the homoleptic complexes. The first kind of the complexes we are having are the homoleptic complexes. What are homoleptic complexes? Means you just see here K3FeCN taken 6 times. I am quoting an example. And second kind of the complex name and example also I will furnish, then you can understand better. That is a heteroleptic complex. Homoleptic complex and heteroleptic complex. For heteroleptic complex, we can write the example FeH2O taken 6 times, 5 times NO. So this is the complex we are taking, which is having a di-positive charge. Here you can see in this complex the central metal ion attached to only one kind of the ligand. In this complex the central metal ion is attached to 2 different kinds of the ligands. So based on the number of kinds of ligands, here we are having only one ligand, so they are called as the homoleptic complexes. Here we are having 2 different kinds of the ligands, so these are called as the heteroleptic complexes. Next we can classify the complexes based on the number of kinds of the central metal atoms. The fourth parameter used for the classification of the complex compounds is number of central metal atoms or central metal ions. Based on the number of central metal atom or based on number of central metal ions, here we can classify the complexes into two different types, homonuclear, because here nucleus means center. That means here the central metal atom is considered as a nucleus here. Homonuclear complexes. If in a complex we are having only one kind of the central metal atom or only one central metal atom, they are called as the homonuclear complexes. All the complexes what we quoted here are examples for the homonuclear complexes. Or else let us take an example. CONH3 taken 6 times plus 3. So here we are having only one cobalt atom, CO, cobalt. So it is an example for the homonuclear complex. For example, if we are having more than one central metal atom, they are called as the heteronuclear complexes. Homonuclear complexes and heteronuclear complexes. Heteronuclear complexes means there we are having two different central metal atoms or central metal ions. We can take an example, Mn taken twice, CO taken 10 times. Here it is a neutral complex having two central metal atoms. So these are called as the heteronuclear complexes. This is what about the introduction about the coordination compounds. If you like this video, please like, subscribe and press the bell icon. Thank you very much. Thank you friends.